Once there was a time when man believed that the earth and himself were the center of all creation. A cozy point of view. And quite reasonable to the average man watching the stars and planets wheel across the heavens. But one man, a Polish astronomer named Copernicus, proved mathematically that appearances can be deceiving. It took a while for the world to accept that. And since then, man has come to rely more and more on modern science to reveal the nature of the universe. Yet it is still possible to be deceived by appearances. Today, scientists think that there might be something radically different about half the stars in the universe. A difference impossible for a man to observe by looking up at a night sky. And even with advanced scientific equipment, it would be difficult to detect this difference in a star or one of its planets. There is, however, one sure way to tell. Should anything from our world come too close to one of these different stars, it would be instantly annihilated. Then he would know the difference. This different world is made of antimatter. Matter. All things on Earth are composed of matter. To understand what matter is composed of, we must penetrate the microscopic through the cells and the molecules until we come to the atom. The atom has a nucleus of protons and neutrons. In orbitals around the nucleus are electrons. Protons carry a positive charge, and electrons a negative charge. Neutrons are neutral, carrying no charge. All matter is composed of these particles and charges. But some scientists were puzzled. They wondered why the nucleus should always be positively charged and the smaller electrons always negatively charged. Could there exist an atom where these charges were reversed? The name coined for this reversed matter was antimatter. The existence of antimatter was predicted by mathematical calculations in 1930. 2 years later, in the cosmic rays from outer space, the first piece of antimatter was discovered. As cosmic rays bombarded a cloud chamber in a magnetic field, a photograph was taken, showing tracks of the formation of two particles. One was an electron carrying the expected negative charge. The other looked like an electron, except it spiraled in the opposite direction, indicating a positively charged electron. It was named the positron. This was antimatter. Then in 1955, the antiproton was found. The antiproton was created in a particle accelerator, better known as an atom smasher. First, a proton was accelerated in a magnetic field, thus given energy. The proton was then smashed against another proton, releasing the energy. This energy was instantly transformed into two more particles, a proton positively charged and the antiproton negatively charged. Soon afterwards, an antineutron was discovered. So now there are anti-electrons, antiprotons, and antineutrons, all the ingredients necessary to form anti-atoms, which could form anti-molecules, anti-cells, a world made of antimatter. But the fact is, no antimatter exists on Earth. Within a fraction of a second, the created particle of antimatter will collide with a particle of matter. The two particles are then annihilated, turning back into energy. If a piece of antimatter the size of a baseball came in contact with the Earth, it would release the energy of an atomic bomb. It is conceivable that whenever a particle of matter is formed from the energy in the universe, its twin antimatter is also formed. Conglomerations of these particles could then form stars of matter and stars of antimatter, and possibly galaxies and antimatter galaxies. What if an inhabited anti-planet were found? Both science fiction writers and physicists have speculated about what might be found in such a world. One of the more intriguing ideas suggested is the concept of reversed time, anti-time. Even physicists are finding it difficult to understand what it means for time to go backwards. Mathematically it works, but physically it is close to impossible to conceive. Anyway, we could never visit such a world, for without a doubt we would be annihilated. But although we can't go there, perhaps antimatter could come to us. In 1908, a meteor fell in Siberia, witnessed by Tungusian farmers. The explosion was large enough to burn and flatten trees in an area 32 miles across. From the magnitude of the explosion, investigators calculated that the meteor must have been gigantic. They searched for the fragments and remains that such a meteor would leave behind, but no trace of meteoritic material was ever found. Some have since suggested that the Tungusian meteor was made of antimatter. Until now, the existence of antimatter has been used primarily to help understand the nature of the universe and to explain strange phenomena such as the Tungusian meteor. But in the future, perhaps antimatter could have more practical uses. Consider the possibility of exchanging garbage with an anti-world. Not only would we rid ourselves of unwanted refuse, but we could derive a great amount of energy from the controlled annihilation of their anti-garbage. a source of clean, pollution-free energy.